Hey Moby, where have you been? I got a letter. It says this girl telling her mom about black holes, and her mom called her Einstein. She's asking why her mom called her that when she's talking about black holes. You see, she doesn't understand how black holes and Einstein are connected. Beep, beep. Well, yeah, I guess we did make a black hole video, but we didn't describe black holes' connections to Einstein. You see, the idea of something like a black hole was first proposed in 1783 by John Michell in a letter to Henry Cavendish, but it wasn't until later that it was accepted as possible. Einstein's theory of general relativity implied that astronomical objects, such as black holes, should exist. Einstein's theory also explained what gravity was in a simple and easy-to-understand way. Beep. Well, we knew what gravity was, we knew that it existed and some of its properties. However, we didn't know exactly what caused gravity to exist. We didn't know what it exactly was. You see, we knew that a force of attraction based on mass existed. However, we didn't know what caused it to exist. Beep, beep. Kind of. You see, Einstein described all of space and time as a blanket, and all things in the universe were on this blanket. The more mass an object has, the more it bends this blanket. The more it causes a groove in space-time to form. According to Einstein, all things have mass and are on this blanket, except for things like ideas, because ideas aren't exactly real. At least they don't exist in the physical universe. So, the bigger an object is, or not the bigger necessarily, more mass an object has, and an object doesn't necessarily have more mass because it's larger. For example, Jupiter's gravity is only slightly more powerful than Earth's gravity. However, it's a much larger planet. That's because it's made mostly of gases. It's not very dense. So if an object is really dense, it has a lot of mass. So the more mass an object has, the more it bends space-time. And when something bends space-time, anything that comes into that groove or comes in contact with that bend in space-time falls into it and goes towards that object, or at the very least is affected by it. This is the force of attraction we call gravity. Everything we can observe exists on the fabric of space-time, so there is nothing that can completely escape the effects of gravity, including light. For example, if there was a star behind the sun, gravity would cause the star's light to be bent and make the star appear next to the sun. I was getting there. The key to escaping gravity is speed rather than power. It takes speed of 7 miles a second to escape Earth's gravity. Light can move around 186,000 miles a second, which is about 25,570 times greater than it needs to be. Black holes are such powerful sources of gravity that even light isn't fast enough to escape. That means they have a gravity at least 25,570 times greater than Earth. One normally say we can see a black hole by simply having a pure spot of darkness. However, because the gravity of a black hole can distort light if the light does not come too close, because if the light comes too close to the black hole, it gets sucked in. However, if light is far enough away, the gravity doesn't affect it too much. So it would just simply bend the light. So we can't really say that stars that appear next to the black hole are actually next to the black hole. In other words, we can't tell what we're really looking at, if it's a black hole or just a random dark spot in space. Wait. Well, you see, Moby, a human can't even survive the gravity of the sun. So, if we could stand on the sun without being burned, what would happen is all the blood in our body, at least the upper body, would be pulled into our lower body. So we'd have no oxygen flow at all. So we'd die. Also, before that, the gravity would simply just crush our bones and organs. A black hole has much more gravity than the sun. So if you were to get pulled into a black hole, assuming that the gravity wouldn't just immediately kill you, what would happen to you is you would be slowly ripped in half, pulled apart, repeatedly, until you were a string of atoms. This is called spaghettification. Einstein's theory of general relativity states that space-time is a piece of fabric. Some physicists believe that black holes have such immense amounts of gravity that when they cause a bend on that space-time fabric, they actually break it, they rip it completely. Which basically be the same as saying it's a door or a window to outside of the universe, outside of physics entirely. But that doesn't necessarily mean that there are no rules. It's possible that there's just simply different rules. Simply stepping outside of our current space-time wouldn't just allow you to become a god, or wouldn't allow you to just do whatever you wanted. It's very possible it would kill you immediately, assuming we could get there. Of course, the black hole would kill us far before we reach that point. Moby, you can't create a black hole. And even if you could, Stepping outside isn't gonna make you a god. Moby, don't you dare bring